So in this little segment, I'm going to get a little bit technical, and no apologies for that, because I think if you understand the technology that underpins the cloud, you're in a better position to buy it. And the main sort of, there's been lots of changes in technology for the last 50, 60 years, as we've covered in other videos. The main one that's driven cloud consumption in the cloud industry is something called virtualization. And it's quite difficult to explain, but I'll give it a go. So if you think since the 1950s, computers have been getting more and more powerful. And that power in terms of CPU, memory and disk have just got exponentially, you've got more capacity to do things, with that piece of hardware, that computer. And so around about the sort of 1980s, and probably a little bit before that, but it became mainstream in the 1980s, the concept of virtualization was born. And what that is if you take a computer, you can carve it up into little bits and make it look like multiple computers. Now that's a really bad way of explaining it, but bear with me. So if you think you've got a big server, a big computer, it's probably got, it can do 100 things at a time, but most of the time it's only doing one or two. So if you're a business and you're looking to save money, rather than buying another computer, which is really powerful, you buy a piece of software called a hypervisor, which is a virtualization piece of software. And what that does is it fools the big computer into thinking it's lots of small computers. And they're called virtual images or virtual computers. And those virtual computers have got the same attributes as a physical computer. So they've got virtual CPU, virtual RAM, and virtual disk, okay? So, diving a little bit into the detail, and I'll use made-up units. If your computer, your physical computer, has got 10 CPUs and 100 gig of RAM and a terabyte of disk, you could actually split that into 10 computers, 10 virtual computers, each of which have got one CPU, one virtual CPU. I'm running out of the maths now. 10 gig of RAM and 100 gig of disk. So you can carve it up, and that basically is using the whole physical computer, but you've effectively turned it into 10 still fairly powerful computers. And so you can start getting quite clever about putting workloads into virtual computers that are sized to do what that computer needs to do. So that's the sort of general principle of virtualization. It's all about taking a physical asset and carving it up into smaller pieces that operate in the same way as the physical asset, but basically are virtual. Now, if you think through some of the implications of that, it's pretty profound. A physical computer, in my example, with 10 CPUs, we've created 10 virtual computers. I'm struggling to remember what I've just said, but just bear with me. If they've all got one CPU each, but 9 of those virtual computers aren't actually doing anything, you could allocate all 10 CPUs to the one that's doing something and make it go 10 times as quick. That's a clever way of using your resources, sharing resources across all those 10 virtual computers. You could switch the virtual computers on and off again. Because it's all software, you don't have to go into a machine room and switch the physical computer off. You can switch the virtual computer off, and then you're not using any resources at all. So virtualization has created software-controlled IT, because you can reallocate the physical resources however you see fit. And as the hypervisors and some of the virtualization engines have got better over time, they've become very, very clever about what you can do with these virtual computers. Now, if you play this into cloud, all of the things I've just described underpin cloud computing. And the reason why it's relevant is you've got your physical computer. In my example, you've got 10 virtual computers on my big physical computer. People like Microsoft and Amazon, all they're doing is buying massive computers, physical computers, and carving them into lots of virtual computers. And then they sell you a piece of virtual CPU or a virtual RAM or virtual disk. So they're selling you it's not a physical computer, it's a virtual computer that sits on their massive infrastructure. And these guys, we're talking tens of thousands of computers sat in big warehouses in the middle of the desert, powered by solar power. It's all massive stuff. That is really what the cloud is. And it's all enabled by that combination of technologies getting more and more powerful, and you're able to virtualize it. The other thing that does is don't know what's going on with the seat. Your virtual computer, you can have a virtual computer sat on the same physical server as another customer. So they can share physical assets across multiple customers and multiple clients. They can start getting really clever about the fact that you've got this massive physical computer. They can allocate CPUs you're not using to somebody else. And so what they end up doing is what they call contend, or overshare the physical assets. So they're maximizing the amount of money they're getting by sharing it to multiple customers. And in that context, running a cloud computing service as Microsoft or Amazon is pretty complex, but it also can be massively profitable. And if you look at things like Amazon Web Services, which is their IT arm of Amazon, they are the most profitable line of business within the Amazon retail group. The actual book selling bit doesn't make much money. Amazon Web Services makes a fortune. But it also means that those companies are having to invest massive amounts of money on computers because they're growing at such a rate. And also, when you as a buyer are buying cloud computing, you just assume that their infrastructure is going to be there and working. So that virtualization layer allows AWS and Microsoft and Google Cloud Platform to do really clever things about sharing the workloads across physical assets, building resilience, building extra capacity, allowing it to scale. That's what cloud computing is all about. So, didn't get overly technical. I could probably go a bit further if you want me to, but I'm not going to. I think the premise of this is, if you understand what virtualization is, 9 times out of 10, if you're buying an IaaS service, an infrastructure service, you'll be buying a virtual computer that's doing something, and that virtual computer will be specified as virtual CPUs, virtual RAM, virtual disk. All it is an image sat on a big physical server somewhere owned by the cloud provider, somewhere in a data center, and they're carving out across multiple clients. And that is why virtualization is really important to understand, because you're not buying something physical, you're buying something virtual. And that lends us back to what I said in the introduction. If you're diving into the commercials of this, when you buy a physical asset, you can put it on your books, on your balance sheet, you can amortize it over 5 years. It's a fixed cost to the business, and that's all fine. When you're buying and that'll be capex. When you're buying a virtual server on a shared service from somebody else, from a cloud service, it's an opex spend. It's operational expenditure. It's part of a service being delivered by another company. So there's some fundamental different financial treatments between cloud and hardware, buying your own hardware. Anyway, that's virtualization. I'm diving into some other topics now, which I probably shouldn't do. We shall get the boat a little bit more stable because it's wobbling all over the place, and then I will have a look at what the history of cloud computing is.